Assalamualaikum and a very good day to you all. In this video, I would like to share with you on how to show that a function is one-to-one graphically. Now, what does it mean? Why bother about one-to-one function? Because if a function is one-to-one, then the function has an inverse. Okay, so we can reverse the process if we want. So, and secondly, what does it mean by graphically? Okay, graphically means we have to sketch the function, and then we do a test that we call horizontal line test. Okay, now why bother having horizontal line test? Okay, we want to make sure, okay, let's say we have a function like this, okay, and then we do horizontal line test like this. We take one horizontal line and then we put the line. Now, if the line has more than one intersection like this, it means that the function is not one-to-one. So this one, two intersection, okay, therefore not one-to-one, okay, and also no inverse, okay, no inverse. So this is what we want. Actually, we want to know whether the function has an inverse or not, okay, by performing horizontal line test. Now, if we have another example like this function, okay, this is x, this is y, and then we do a horizontal line test. Now, as you can see here, if I move the red line up and down, okay, if we move the right line up and down, it always touches or intersect at one point with the function, the linear function. So in this case, we have one intersection, therefore it is one-to-one and it has an inverse. Okay, so don't worry too much if it's too fast for you. We do the example one by one, and then I will explain it one more time lah. Okay, now let's get started with this one. Okay, so this one means that depth to the right, and then it will go through -1. So it's supposed to be like this, and then this is label our function fx, and then okay, for this line you sketch a straight horizontal line over here, and then label it y equals k. Now, as I said just now, if you want to test, okay, since you can use your ruler or another pen, and then you make the pen horizontal and then put it against the function and move it up and down like what I did with the red line. Okay, as you can see here, as I move up and down, the blue function always intersect one point with y equals k. So therefore, since y equals k, intersect fx once, okay, therefore fx is one-to-one function. Okay, fx has an inverse. So this is how to write it. This is how to solve it. So we sketch it first, and then we sketch a horizontal line, label y equals k, and then we try to trace it up and down to see whether it always intersect once at every point in along the function that we test with, and then we write the conclusion like this. So 3 steps lah. So let's move on to the second one. This one is a frown shape. Okay, frown face, sorry. It's a quadratic, so it should be like this lah, going through origin. So this is our gx. Okay, unlike the second one, unlike the first one, if we have horizontal line over here, y equals k, as you can see, no matter if I move it up and down, like this, you see, it always intercept 2 points. It always intercept twice. This one, intercept twice. Intersect twice. Okay, so what we can write, since y equals k intercept gx more than once, therefore gx is not 1-to-1 function. Gx has no inverse. This is one example that a function has no inverse. It is not 1-to-1, therefore has no inverse. Now, let's move on to the third one. So this one, cubic. Cubic should be something like this, going through the, or not going to the origin, my bad. Should be something like this. Better. So hx, this one is 3. Okay, now we sketch a horizontal line over here and label it y equals k. So for this one, we see no matter the red line going up or going down, it always intersect once with the blue line, blue curve. So since y equals k intersect hx once, therefore hx is 1-to-1 function. Hx has an inverse. Now let's move on to the last example. So this one we should get the point first, the starting point. The starting point is minus x minus 2 equals 0. So x equals minus 2. So the point at minus 2, I just take the y over here. Now we need to know the shape. Since this is positive, so it's going up. Since this is negative, it's going to the left. So let's locate where minus 2 is. Minus 2 is somewhere here. Minus 2. So our function is like this. So this is our function. This is our mx. Now we put a horizontal line, and then label it with y equals k. Now as you can see here, this one also, no matter how you drag the red line up and down, it always intersect once with the blue curve. So since y equals k intercept mx once, therefore mx is 1-to-1 function. Now mx is has an inverse. So I think that's all. Thank you for your time and attention. Assalamualaikum and have a good day.